Good morning. This video is for Math 245. Today is March 20th. This will be the first video of 4 little lesson videos that I'll be posting on Canvas for this week's lesson. Before I go through that first part of the lesson, I do want to go over one of the that one announcement that I made on Canvas. I found out that Nuva will remain on remote learning throughout spring semester. That means we won't have face-to-face meeting anymore. I will miss you guys, but I still have to plan for the rest of this course. So the big ones first. I'm planning on giving you exam 2 and exam 3 as take home. Because I don't want to make exam to be such a big part of the grade. I'm gonna make them to be now only 45% of the course grade instead of 60. And I will make the data assignment and homework, the My Math Lab homework, to be 25% each now. I still have the attendance as 5%. What I will do is since I decided not to have like a synchronous live class every Friday at 11 to 2, I'd rather just record and post those videos. So in case if you cannot make those sessions, I will still ask you to watch all the lesson videos and try the assignments. I'm probably gonna create short activities, like maybe like a Google form, like a little survey, or those things for attendance grade. But I'll make sure to give you a clear direction on how to complete those as attendance activities. Okay. I'm planning on it's 10 o'clock right now, so I'm starting a little bit early. I'm planning on having everything posted by 2 p.m. this afternoon. That's when we usually get out. And still, we're gonna have a whole week to work on this week's assignment. I'll ask you to complete everything by next Thursday, March 26th. So if you are working on Canvas like at 11 o'clock this morning, and if you don't see everything posted, I'll make sure to have them all online by 2 p.m. And I really appreciate your patience as everybody's kind of going into this new way of teaching and learning this semester. But if you have any questions, any issues, internet or like technology, anything, please email me. Let's see if you know my email address. Here you go. My email address is sson@nvcc.edu. Email me. What we can do is we can make I can schedule like a Zoom video conference for our office hours. Or if you can if you just want to email, that's also fine too. But please know that I check my emails like all the time now. So please email if you have any issues, questions, okay? But now let's well, on Canvas, I see this assignment grid updated, so you'll also see that. Let's go to modules. Please go to modules. This is where you find all your slides. I'm gonna have one more listed here. I think I'm gonna go to 6.3 straight from 6.1 later. I want to talk about binomial distribution and save the normal distribution for next week. But I do want to finish chapter 5 first today. So chapter 5, we were talking about probability, and before spring break, we talked about conditional probability briefly. I do want to review that one more time. So I'll start with chapter 5, contingency tables, and conditional, joint, and marginal probability. And after this slide, I will ask you to work on data assignment 3. It's a very short one, only 50 points. It's got 10 problems. But the goal for this video is for you to learn, for you to watch and learn and master all these things that I prepared for you on the slide, contingency table. And after we go through this, I'll briefly talk about the assignment. Data assignment 3, contingency table, and probability. And it is posted on Canvas for you. This is what I'm going to ask you to do by next Thursday. It's got 10 problems. I'm just asking for some conditional, joint probability, and the last one is about relative risk. But you will have to download this Excel file for data set and upload it on stat crunch to do this, but we'll talk about this after we go through the slides first, okay? So let's get started. Let me go ahead and present. Now I really don't have the Word doc for you to print out too, but if you want those fill-in notes, I can post those on Canvas for you too. But I thought maybe we could just watch and learn. But it'd be a good idea for me to post those notes too. But anyways, all right, let's start this. Contingency tables and 3 different probabilities that we will calculate from that table. What do I have to click to make this slide go? Guys, I'm clicking. Oh, there we go. The contingency table is sometimes called a two-way frequency table. And actually, you've made one before for me. It's going to have at least 2 rows and 2 columns. And we will use categorical data and use the frequency counts to fill out this table. Let me show you the one that you created for me on data assignment 2. Ta-da! In data assignment 2, I gave you a data set where we asked people, do you like wheat toast, white toast, biscuit? And you created this for me already. So you know what contingency table is. You know how to calculate. You did one probability question based on this for me. So this is what I want to go over in this slide with you. The one probability that you found for me was just marginal probability, marginal being probability being using the numbers on the margin over here, totals. But this is what it is. Let's use this table. Let's use this table to calculate some probabilities in this slide, okay? All right. Now here's an example for you. 130 people are in a room. The table shows how they fall into the indicated groups. On the left side, we have them grouped by their age, under 25, 25 to 35, 40 to 59, and 60 or more. And on these columns, we have Republican, Democrat, Independent, and as you can see, the far right column, and then the bottom row right here, these are the totals, okay? One day, I think it was before spring break, I asked you to find these totals, but these are just going to be the sum. The 28 is from adding 10 plus 15 plus 3, so it looks like out of 130 people in the room, 28 of them were under 25, and out of 130 people in the room, 59 of them are Democrats. So using this table, we know how to read the information on this table. Let's go ahead and find some marginal probability first, okay? So first, find the probability that a randomly chosen person is under 25, So out of 130 people total, remember we said that there were 28 people who were under 25, right? So the probability will be 28 divided by 130, so that will be 28 over 130. I'm just going to leave my probability as a fraction. I know it's not reduced, but you can see clearly where my numerator and the denominator came from. Real quick, I'm typing this into my little calculator, and I got that to be about 22%. Okay, now let's find the other one. Find probability that a chosen person is a Democrat. So again, out of 130 people, how many of them were Democrats? The total were 59, right? So let's do 59 divided by 130. Therefore, the probability that we want is 59 over 130. And let's see, so if I divide that in my calculator, I got that to be about 45%. Okay, now guys, these are called marginal probability because I'm really just using the margins, like the totals, these rows and columns all the way on the right and all the way in the bottom to find the probabilities. These are called marginal probabilities, okay? Now let's look at the different type. The second type is called joint probability, okay? So let's read. Find the probability that a chosen person is a Republican and that person is in between 40 and 59. Now let's see where that is. We can choose anybody in this room full of 130 people, right? But how many of them are Republican and in between 40 to 59 in age group. So let's see, Republican, 40 to 59. So I need my numerator to be 15. 15 over what number? 130. Therefore, the probability that we want is 15 over 130. Okay? Oh, you see there's number 2 that I got listed right there. That's not what I want. Probability of Democrat, that's I think I didn't change the what's it called? The problem from the previous slide. Let me go and see. Okay, now it changed. Alrighty. Find the probability that a chosen person is a Democrat and under 25. So still we have a room full of 130 people, so that will be my sample space. But how many were Democrat and under 25? Oh, there were 15 under 25 Democrats there. So what we will need to do is 15 divided by 130. Therefore, the probability that we want is 15 divided by 130. Now they happen to come out to be the same. So what we are saying is we have the equal chance of picking somebody who is Republican and in between 40 and 59, or a Democrat and under 25. But they just happen to come out the same. But that's how you do joint probability. You have to use we had to use one of these numbers in the table, but still the denominator was still 130. Now, this is the conditional probabilities, the third one. That makes so much sense in a table, but I want to make sure that you know how to read this notation. This is something we did before spring break. Let's read the first one. Find the probability that a person is Republican given that this person is in between 40 and 59. So look at what I typed up here for you. Republican given this person is 40, in between 40 and 59. So my total is not going to be 130 this time. I'm only interested in the group of people who are in between 40 and 59. So take a look. 40 and 59, there are only 31 people there. 31 people. And out of 31 people, how many were Republican? So 15 people were Republican and in between 40 and 59, 42, 59. So my probability here will be out of 31 because there were only 31 people who were in that age range. And my numerator will be 15. So therefore, my probability, my conditional probability will be 15 over 31. Now notice for conditional probability, we are not using 130, the total for our denominator. I was using 31, and that was from the given part, okay, the part that comes after. Now let's do 2 more because this one was a little bit more confusing than the other ones. All right, number 2. Find the probability that a chosen person is independent given he or she is 60 or more. So what do you think the denominator for this probability is? The denominators, and it's not going to be 130. Tell me how many people were 60 or older. 36. So we're looking at out of 36, how many of them were independent? And that number is 10. Therefore, that probability is going to be 10 over 36. I just have one more, the last one. Probability that a person is under 25 given he or she is an independent group. So what is the denominator this time? We're looking at how many of them were in independent group, and that was 25 for my total. And how many out of those 25 were under 25? 3 were. Therefore, that probability is going to be 3 out of 25. Okay? All right, now this one, we're doing something a little different, but still, I want to keep on reviewing this conditional probability just because that notation looks just a little different. But now let's take a look. We have the second example, 1,150 people were broken into the following categories. Let's see. So we have some smokers, By the way, how many were total number of smokers? Now I can see there were 400 smokers who had diabetes and 170 smokers who don't have diabetes. So if I add, it would be nice to have that maybe on a piece of paper. Will you write that down? So do 400 and plus 170. Write down that there were 570 smokers in total, right? Because I want to test something. Now, I checked this, what's it called? Document camera out from Woodbridge Technology Center. I want to see if this works. All right, give me 1 second. Because I always just record on the... Oh, yes! I'm recording my screen. And... Hello. I'm just gonna... Oh, this is fun. I'm just gonna go ahead and I need my table though. Give me 1 second. I'm gonna copy down the table real quick. So the table was diabetes, no diabetes. Hold on. Smoker, non-smoker. If you're wondering what are you doing right now, I'm trying to create the margins. Okay, so let me show you what I wrote down on my paper, okay? Zoom, zoom, zoom. You're seeing my computer screen. I copied this down real quick. Oh, it looks so bad, but I did this because I wanted to find the totals on the side. So extending my table over here, total. And if I add these two, I will get 570. If I add 230 plus 550, 350, I will get 580. Oh, we had 10 more non-smokers than smokers in this part. Hold on, let me go ahead and find the totals in the bottom here too. I suggest you do that on a piece of paper if you can. All right, so what goes in here? I will have to add 400 plus 230. These two will add up to 630. And let's add these two. 170 plus 350, I got 520. Now take a look. If I add these two numbers together, 630 plus 520, I got 15. You see my little calculator, 1150. But I want to double check if I added everything right. If I add these two together, guys, 570 plus 580, I do have, oh yes, same number. So this table's good. Now, it will be helpful to have the totals, the margins completed in order for you to do any marginal probability or joint probabilities. So I suggest you write this down on your paper, okay? I have mine over here, but I'm going to go back to my slides now, okay? I didn't have that over here, so it'll be nice for you to have it. So I'm going to go ahead and start back. All right, what's next? What do I have to hit? Oh, here we go. The relative risk is what I want to talk about. That's the last thing for this video, but I want to talk, in order for me to find those that relative risk, I'm sorry, I don't know what's wrong with my speech. I need to find number one and two. Number one, what is the sample probability for diabetes among smokers? Okay, so what they are asking is, out of how many smokers do we have people who had diabetes? So here's how we find it. There were 570 smokers, right? 570, no. Yeah, 570 smokers. And out of those 570 smokers, 400 of them have diabetes. So what we do is 400 divided by 570. And just to make it easier to see, I converted that into percentage. 400 divided by 570 is 0.70. So approximately 70% of the smokers in this sample, not in general population, guys, in this sample had diabetes. Okay, now the second question, what is the sample probability for diabetes among, non-smokers this time? So how many non-smokers did we have? non-smokers, when we added the 230 and 350 together, we had 580, right? And out of 580, it looks like 230 of them have diabetes. So this is what we do. We do 230 divided by 580. And if I type that in my calculator to get a decimal, I got 0.396. So I'll round that up to about 40%. Okay, now these two are different numbers, right? So what can you tell? At least in this sample, we had more people with diabetes among smokers. So the last question, here you go, is called relative risk. What is the relative risk of diabetes, smoker versus non-smokers? And this is how you calculate this. Take the number that you got from smokers, the answer from number 1, and divide that by the answer that you got from the non-smoker, number 2. So the relative risk is going to be 0.7 or 70% divided by 40. And that's going to be about 1.75. What we can say is that at least in the sample, the people who are smokers were 1.75% more likely to have diabetes. Okay? But be careful with the way that we divide it. It says smoker versus non-smoker. So I just divided the 0.70 by 0.40. And on the next slide, and this is the last question that I'm going to ask you on your data assignment 3, the relative risk. And on number 10, you will have to use your answers from number 8 and 9, and all you have to do is simply divide. The last slide of this is just summarizing what we just talked about. The relative risk, or RR, is simply the risk of event in group A divided by the risk of event in group B. And now this one looks a little more complicated, but you actually did all of these. This table that I found just uses disease, normal, or exposed, non-exposed. But you can see how the total from this first row right here is A plus B. This column right here is C plus D. And then they also showed you how they got these column totals. But everything, the total of total, is going to be just adding all those boxes together. Those look a little complicated, but you did this already with me on this previous example. So I do want you to try everything that we just talked about. And that's it for my slide. That's it for my short lesson. Now, I hope this was helpful. I hope you learned this. What I want you to do is like a little formative assessment is this data assignment 3, and I'm going to create more and more of these. I was only going to give you 6 data assignments this semester, but with us going virtual, I'm thinking we can do more of these and make the exams a little bit shorter, or so I'll ask you to do more work at home and submit so that I can see. Let's talk about this real quick, okay? Data assignment 3, I want you to maybe like after, you can stop the video and then try this for me before you start, because I'm about to start chapter 6 after this video. Data assignment 3 is about age and arthritis. Upload the file arthritis data set into StatCrunch. This file contains data on 76 individuals. It's just a sample, guys, and I'm not saying this sample was randomly selected. So it's not, we can't say this applies to the general population, but just a sample that I found, or actually I created. The variables are age group, which is under 40 or 40 and over, and symptoms of arthritis, either yes, they have a symptom, or no, they don't have a symptom yet. What I want you to do is, in order for you to answer 2 through 10, you will have to create a contingency table. Okay, and I typed up exactly how you're going to do that. Click Stat, Table, Contingency with Data. You've done this before with the TOAST data set before, so I know you will be okay. Now, you do not have to copy the chi-square table or anything. I just need you to do the contingency table. Now, copy that table down right here for me. And then using that, I'm going to ask you to answer or find some of these marginal or joint and conditional probability, okay? And number 10 is the one about relative risk. I think you should be, I think this will be all right based on what we just talked about. Submit this for me by next Thursday, but as soon as possible if you can. I'll just grade it out of like 5 being correct, 0 being incorrect, but you can submit as many times as you want if the answer is not correct on your first attempt. Now, that's open for you. and I'm going to stop the video for this part, and I will come back and record another one, the second one for the 6.1 probability distribution introduction, okay? And thank you so much for watching. I hope you're having a good morning.